In this lesson, guys, what I'll be doing, I'll be proving this question. Here I got my left hand side, and here I got my right hand side. So right hand side. So here, guys, what I shall do, I shall decide which side I can take that I can simplify. By the way, here I shall decide which side I can simplify. Yeah, so between these two sides, and when I simplify that side, I shall make sure that I get same as this side. Then if I take this side, I shall make sure that this side is look the same as that one. But what I prefer, guys, I prefer for you to take the side which is complex. The side which got some brackets, take it that side, because you will expand those brackets until you get this thing. So let me take this side. So my left hand side, this is what I have them. That's x plus tan x2 minus by this x then. So on my left hand side, guys, here I got this negative which tell me about this term even as well as that term. So in this term, this side here, I'll only simplify this term there. Here I will minus this thing. Here I will minus it. I won't focus here. I'll only focus here. And when I focus here, I'll only do two brackets there. Then this one there, I will keep it the way it is. Meaning this thing there is cos x, tan x, tan x. And here they got those two plus. Yeah. So that 2, guys, it represents this thing. It's twice, as you can see. And now what I can do, this will multiply here 1, this multiply here 2, multiply here 3, and multiply that, that's 4. Okay, so meaning that these two things, when they multiply there, they give me a cos squared. This they multiply there. When we multiply different base, we keep them the way they are. But when we multiply same base, we just add their exponent. We add those invisible one, they give us 2. But here when we multiply different base, we keep them the way they are. Then this they multiply at different base, we keep them the way they are. But here when we multiply same base, we'll add their exponent, which is 2 there. Do you see? And this, I keep it the way it is, because I won't affect it. And now if you can take a look there, this, it's a like term with this one, because all the bases there, they look the same. And here we got invisible 1 here. We got invisible 1. So because these two things, guys, are like term, I'll only press this down my calculator. 1 plus 1, obvious, 1 plus 1, it's 2. Then you just keep their base the way they are. Even as well as this tan, then 2 sine x, then here it's plus, then coming from here it's 2x there. Do you see? So now what I need you to understand is that here we're no longer having what like term here. No, we don't have no like term here, because here it's only cos, while here it's cos and tan. So these two things are not like term, and here we only got tan, while here it's cos and tan, meaning these two things are not like term. And this one now, it has sign there. Here there is no sign. So here we don't have like term. The only thing that I can do here, let me try to simplify this thing here. Let me try to change tan. Let me try to change that tan. This one, guys, I will just keep this tan the way it is, because according from what I'm proving, I already have that tan, which is this is that tan. Even as well as this cos, I can say it's already there. The only thing that I will focus, let me try to simplify this thing. Try to see what will I get after simplifying this. So this thing there, it's sine over cos. Then everything now, let's just keep it the way it is here. So here it's just cos and plus here it's 2 cos. Yeah. And here's guys a key thing, because this thing it got its own brackets, let's put this thing there on its own brackets, and I will put invisible one. And now I know those brackets, they represent what? Multiply. And when I multiply fraction, numerator to numerator and denominator to denominator, just like this there, so that this thing now, this will become as cos and sine x divided by what? By cos x plus tan, and say minus by sine x, which is here, it's plus cos 2x there. Yeah. And when we divide, the same thing, they cancel, then we end up having this thing there. This thing there, it's plus 2 sine x plus tan 2 minus by what? By tan sine there. So here's guys a key thing. If you can take a look, this is the like term with this one there. And then if I can press this there on my calculator, pressing plus 2 minus 2 plus 2 minus 2, you'll end up getting 0. And because that we get 0, it means that these two things, they will end up cancelling. And now when they cancel, this is what we'll end up with. We'll end up with cos x and plus tan x there, just like this there, which is, this is what we are proving, by the way. It is what we are proving here. Therefore, left hand side equal to right hand side. This is what I'm proving there. Do you see? Yeah. So this question, guys, you should be smart and know what you should change and know what you should not change. So here, only change this tan there, because I keep that tan, because I keep this tan, I keep that tan there, so that that tan there will help me to prove what I want to prove there. Do you see? Yeah. So I'll be proving these things. I'll be proving that this side, it's equal to that one, which is our left hand side and the right hand side. I shall prove that those two sides are equal. And for me to do that, I can decide the better side that I can take, by the way. The one which kind of complex, this or that one. I can take the side that I can simplify. Yeah, that is the only thing that I can say. I should take the side that I can simplify. So these two sides, guys, it's kind of difficult to understand which one you can simplify there here. Because someone else, when you say that exponent 4, you don't have the rule or the identity which symbol says that you can simplify that 4. Do you see? But this left hand side, guys, it is the better option for you to take, by the way, because on my left hand side there, I can apply what you call difference of two squares. That thing, it's a part of factorizing them. Just know how to factorize, guys. If you don't know how to factorize, I will suggest you to go and revise factorizing. Do you see? Yeah, I'll suggest you to try to revise factorizing. Guys, in grade 11, by the way, just know how to take a common factor, know the difference of two squares, and just know what to call trinomials. At least if you can know these three types of factorizing, you will be good. And here we don't have a common factor there, so there I can't take a common factor. But difference of two squares, there I can apply them, because this thing there, it is in a form of minus pi. This thing, it is in a form of, we got two terms which are separated by negative, and then we can halve the exponent. So the only thing that I will suggest you, just factorize this thing like this term, even as well as this. Then you'll do two brackets, just like this term. Do you see? So once you do those two brackets, now you will take the square root of this. When you're taking the square root of a base, you halve the exponent, meaning that I will halve the exponent like this. At the same time, I will do it there. Do you see? And when I take in the square root of this thing, I'll have the the exponent. When I'm taking the square root of a base, I have the exponent. That's cos 2. And when you see negative, you just put plus and plus or minus there, plus and minus. And now what I need you guys to understand is this one. Is this then? I don't see my blue pen, but I'll just use this thing. Here I can see all of this thing there. It's what we call identity. And all of that thing there, it's supposed to give me what? It's supposed to give me 1 there. It's supposed to give me 1. Which is that one, guys, will just disappear. That one will just disappear. Because this, it's something like this will multiply here. And anything when you multiply with 1, you just get the same thing. Do you see? Which is this thing there. It is what I'm proving there. Do you see? This is what I'm proving. So now I can just conclude now. Therefore, left hand side equal to the right hand side. Just like that then.